Alright, DraftScience video. Just found a tick on me. Little fucker. On my foot. Bastard ticks. Anyway. Penicillin, maybe. Anyway. That's just so irritating. I got the bad back, and now I got, maybe limed. Anyway, so, but I have been productive. So, I have this piece of paper, see? This is the future right here. This will be worth $1 million someday. Yeah, it really does, I mean, it's helping me anyway get to some of this structure problems of, the idea that polarization is the thing that's defining interactions, and it's the exchange of that polarization, that feature. That change is the only change that really takes place in the universe, is the exchange of that polarization, and that's what makes force visible. Anyway, but we'll get to that. I gotta get a better position for my back here. I really am quite not well. Not as well, not as good as I could be. Really, I can't complain. I'm not, but it's just not good. Especially right now, I got all this shit I gotta do that's, physical shit. And I'm physically broken. But anyway, can't. Anyway. So, a couple of weird things. Alright, so some idiot left this idiotic remark. The real Miles Mathis denounced this guy as an imposter on 25th August 2016. This is some kind of detective guy, I guess. It didn't denounce me. But anyway, so it's this link to the update page. Now, the weird thing about the Miles Mathis guy is this. Okay, so he does these scientific papers that, I've been reading. And most of them aren't crazy. I mean, there's a couple in there that are just crazy. Stephen Hawking died 15 years ago and was replaced by a duplicate. That kind of... You're just like, what the fuck are you doing that shit for, crazy person? Anyway, but he has two websites, Miles W. Mathis and milesmathis.com. And they both have an updates page. And I didn't know about this Miles W. Mathis page. And it's all these crazy stories about how he doesn't think the O.J. Murders happened. He doesn't think any murder in history happened. Pretty much. I mean, it's just the silliest shit. I mean, just stuff I couldn't understand any of it. I couldn't understand how a smart guy could waste his time on this crap. Really long articles about silly things like Marcia Clark isn't Marcia Clark or something, by comparing a photo when she's 40 to when she's 55, and the guy's an artist, a portrait artist, and you're like, how can you not see that it's obviously the same face? It's just, yeah, she probably gained 30 or 40 pounds, but I mean, everything's in the right position. The geography is perfect. I just don't know how could he make an argument like, I mean, just disgusting. To show these people, like especially the Goldman guy, I mean, it's a horrible thing that happened to these people, and he's just, he's pissing on them, and that's just rude. They were horribly, brutally, nastily murdered. And it just, you don't need to do that shit on somebody else's grave. For whatever purpose, I don't know. Like I said, I had some respect for the guy, but now I'm like, oh fuck, he is a lunatic. Alright, anyway. And his announcement about this imposter. Okay, so we'll go read the announcement. This weirdo wants you to think the real Miles Mathis is a crackpot. Well, I didn't want you to think that before, but now it's the only rational conclusion. He's obviously got some issues. Brain issues. And his opinions are not trustworthy. Well, his opinion that the O.J. trial was faked is pretty untrustworthy. Yeah, trust me, I saw it on TV. Don't follow this paid actor. I don't even know what that means. Obviously, I'm not paid. Don't listen to him. Just read real Miles Mathis works on his website. Yeah, go read them if you want to read some absolute crazy, silly non-fiction. Fiction. I don't know why I keep... The word should be faction and non-faction. Yeah. No confusion that way. Fact-based versus bullshit-based. So anyway, this is his other updates page, and it's just got everything in here. So, Scott Fitzgerald, Spook Baby, I don't even know what that means. Leonardo DiCaprio, Italian, question mark, I don't know. Karl Marx was a Rothschild. I mean, just all this crazy, kooky crap. I mean, just really disappointing. Alright, anyway. Announcement added to 2516. Some of my readers have been confused by a guy on YouTube with a channel called DraftScience. Now, anybody who could be confused has got to be so fucking dumb that there's really just no point in even talking to you, right? I mean, Miles Mathis is obsessed with his name, Miles Mathis, in the first place, milesmathis.com. And so he would be mentioning it all the time. He'd probably have it somewhere in the channel description if he had a channel. He'd certainly be pointing out, I'm Miles Mathis, in every video. You can't have read Miles Mathis' stuff without knowing that, so I don't know how anyone who seriously understood who any of these characters were could confuse anybody, could be confused. But anyway, they think that is me. It isn't. He links to me and discusses my stuff a lot. No, that's not true. I linked to you out of courtesy, which you didn't do, I discussed you in 3 videos, I think, in the same manner I'm discussing you here, which is in some kind of general way, and I did send you an email, but anyway, that you did respond to, apparently, although I haven't watched more, wait a minute, apparently, although I haven't watched more than a couple minutes. So you're drawing conclusions about what I do based on what? Hearsay? Oh, okay. Gee, that's reliable. I don't know him. I mean, the hearsay of commenters, some guy told you so, the same guy who says this is denouncing me, which you're not doing. You're not being very nice, but you're certainly not denouncing me. I don't know him, never have I never talked to him. Yes, I did send you an email though, and have no links to him. Well, I did send you an email, you did respond, so that much of a link exists. Although there is some resemblance. Yeah, I pointed that out in the email I sent you, so it's kind of funny that yes, we look a lot alike, we both play golf, we both are painters. Yes, you do those better than me. Probably, I think, the golf thing, who knows. Yeah, so we do have some parallels, which are kind of interesting, and that we got obsessed with physics, which is also interesting. So I'm just saying this: there's some interesting parallels, and I pointed. I have a photo that's exactly like a photo of him, like when he's 5 years old. I have a photo of me wearing almost the same clothes, and it's just an incredible resemblance. Since he is about my age and blonde, that is about it. Well, if that was about it, you should have ended there. You shouldn't have said this part. His hair is much longer and less curly. Oh. He doesn't sport a goatee, and he smokes. Well, I have sported goatees in the past, but yes, I don't currently do that. And technically, I don't smoke. I vape, but mostly. But whatever. I don't, he says. So anyway, obviously he's not assuming that I'm some sort of impersonator or that I've in some way tried to tread on his name in some way, which I haven't, and certainly now I'll be even less likely to, because obviously I don't want to affiliate myself with cranks who are crazy. I want to find cranks who are not crazy. And yes, it's crazy to post hundreds of very long articles. Like the OJ one has to be, I don't know, 17 pages, 18, I don't know how long article. Stephen Hawking died and has been replaced. I mean, just silly crap that he wasted. I mean, yes, he's a prolific writer, but it still had to take him more than 10 minutes to write all that shit. Put photos together, all this other crap to prove, quote unquote, with the silliest circumstantial evidence ever. Complete nonsense. Look, this shit goes on and on and on. It's just laid page after page after page of crap, you know. Really stupid crap. So anyway, but the art is quite good. Although, as I pointed out before, this has a certain unfinished, you know, he does leave them slightly underdone, in my opinion. Very nice, but just like this one, slightly underdone. You know, very nice, but slightly underdone. Anyway, my opinion. It's the point where you say you're done, and I just would say, he says I'm done a little too soon sometimes, in my opinion. You know, who knows? Oh, I haven't seen this male nude. I didn't see that one yet. I don't remember that in the page, the gallery page. Ah, yeah, so I probably have bigger junk than he does. Yeah. But anyway, so what else? The fall, he calls that. Oh, he didn't really fall anywhere. And such. So, yeah, so I just throw that in there, you know, it's just kind of curious. So, yes, there should be no confusion. I'm not Miles Mathis. I haven't played him on TV, haven't done any of these things. But anyway, I mean, it's just kind of hilarious, like somehow you're guilty because I referenced him, like that was a mistake. A guy who talks about physics, and I reference him, and somehow I've crossed some sort of line. No, I think I've done the perfectly reasonable thing. But anyway, who cares? Now that I know he's crazy, it just doesn't matter. So, enough. Moving on. So, back to the real subject. So, somebody did say something here that was just on the subject of where I'm going to end up. Anyway, I'm going to play the rest of the lecture video. As I stated, I mean, they are pretty good for framing the arguments. Yeah, here it is. So, mindless marbles. Alright, I thought I'd talk about relativity since people are more clear-headed with it. I don't know what that means. After all this time. Again, I don't think there's anything clear about it. I don't think it's yeah, I don't think it's correct. I cannot believe no one has mentioned the Michelson-Morley experiment. Well, why should they mention it? It demonstrates just about absolutely nothing. Even people who have an ether theory would concede that quite obviously the stuff moving through the ether is not moving through something like wind, you know, something like an atmosphere, because there is no wind. They'll concede the planet doesn't slow down as it goes through the ether. So clearly the planet is part of the ether. It's moving through the ether as a perturbation, as a vibration itself. So there's no, it's not applicable to a boat going through water or something. You know. So what would Michelson-Morley demonstrate? It doesn't demonstrate anything unless your assumption is, unless you make the assumptions about what the ether is. So you don't let the people who are describing the ether explain what the ether is. You're going to tell them what their ether is. And you're going to force them to accept your definition of their ether. I think that's silly. This is an extremely important experiment that is commonly taken as experimental evidence of special relativity. I just don't know how you people can... It proves nothing. If you believe in the constancy of the speed of light, it proves nothing. Because why would you expect light to move faster or slower based on something's velocity? If you believe in a constant, if you believe in conservation and a mechanical system, then you would say yes, you would expect it not to, the field not to move. The field doesn't move. Stuff moves through the field. That's, you know. Not that I want to make arguments for the wave nuts, but I'm just saying the wave nuts aren't saying the whole field moves. They're saying things move through the field. So it's like kind of like flipping dominoes, I mean, I could flip it, like if I had a big field of dominoes, I could flip the first domino really, really fast. And very quickly, that speed will be dampened into the speed of dominoes falling. So there won't be any, I can't make the last domino fall down really fast by making the first domino fall down really fast. Because the speed is going to be dictated by the dominoes eventually. And in an idealist sense, when you're talking about, the ether people aren't talking about dominoes, they're talking about a ether that would be even more rigid. And they poke it and something goes through it at a speed and that's it. And you don't move the field. And I could even make the argument that that's true for sound. That all sound is created by something moving faster than the speed of sound. That's how you vibrate molecules. If you move slower, you move something slower than the speed of sound, you won't make sound. To make sound transmit, you have to move something faster than the speed of sound. So it's only vibrations going faster than the speed of sound. Something has to be going faster than the speed of sound. And the whip sort of proves this, because the tip of the whip is what's breaking the sound barrier, and that's what makes the crack. It's a breaking of the sound barrier. Your vocal cords, it's the little hairs on the vocal cords that are vibrating. And they're the thing moving faster than the speed of sound. They're making the sound. They're causing the vibration in the medium. Now, the fact that the medium, the atmosphere, can move because of wind, this is not something people would be arguing about empty space and that ether. They clearly wouldn't be saying there's wind. So Michelson-Morley proves nothing. And from my perspective, obviously my argument is that the energy is already moving the speed of light. And so if I'm moving 500 miles an hour in a direction and I'm carrying energy and I'm going to release a photon, well, the truth is, relative to my position, the photon's going to leave going the speed of light minus 500 miles a minute. It's going to be, it has my speed already built into its movement. So it's not moving extra fast because I'm going 500. It's not additive. It's cumulative. That's what the whole idea of an orbit is that you've collected it, and that when it's going this way and you're going this way, it means it's moving from some point inside of you, inside the bag, to another point inside the bag before it goes down. And it does the opposite in the reverse direction. It just goes a much shorter distance. So it's going long distance at the top, short distance on the bottom, long distance, short distance. But because you're moving, it'll turn out looking like a regular wheel, because your movement will create more road and make it look right, even though mechanically, from its perspective, it wouldn't be right. But yes, I'd be releasing it at the speed of light. Can't release it at the speed of light plus 500 miles an hour. And so Michelson-Morley is based on a presumption I don't think anybody with a rational theory was arguing was possible. So proving something nobody was arguing, that's called a straw man, frankly. So anyway, let's play the straw man, because it just happens to be in this video. So it is funny how coincidentally these things come up. Is that Ken guy actually mentioned Michelson-Morley in his video the other day. So it was in 3 places coincidentally, and it's at this point where I left off in the video. If your last video, I was probably a little further along than this, but it was right at the point where Michelson-Morley was written on the screen, which is kind of funny.
Upwind. And the same thing would be true whether the air is moving through our lab or our lab is moving through the air.
Right, so the argument on sound
is moving through the ether.
Right, so this argument is that there's wind then, but that's all there is. So if my lab was moving through the air, I would be building up wind in front of me. I would be causing a pressure. But if you open the windows to your lab, then you can sort of get the idea that you're not impeding the atmosphere. And then you could release something, right? And you haven't distorted the field. So the thing you release will behave quite normally. It will, I throw a baseball up, it will move, relative to my lab moving but it won't do it at a different speed. It'll do it exactly as I throw it. So if I throw it at a slight angle, it'll move at a slight angle, and none of that will be distorted, because the assumption is that at the release point there was no momentum. That's really the argument. Anybody arguing any of this stuff would say at the release point, at the point of where you start initiating the dominoes to move. So you're moving say 30,000 miles a second. The real point is, if you want to think of light as being hitting a domino, the real argument would be, it doesn't matter how fast I'm moving, because at the moment I'm going to hit the domino, I won't have any momentum, theoretically. And all that's going to happen is the domino is going to be initiated. And it's not going to be because I'm not going to hit it with a moving arm. The perturbation, the vibration, will be caused by the same flick, no matter what speed I'm going. Because in a sense, you're basically turning it into a clock speed, and you're just saying there's a moment where that's initiated, but it's not initiated with momentum. I think that explains.
The Earth orbits the Sun at about 30 kilometers per second, and the Sun orbits in our galaxy at 200 kilometers per second. So there should be a pretty good ether wind blowing through our lab.
Like, again, see, that's the presumption. Nobody who would be arguing ether would be arguing there would be ether wind, because then obviously they'd have to explain why all the planets don't stop, why they don't lose velocity very quickly and crash into the Sun. So clearly they understand there is no resistance, matter has no resistance to the ether, okay, unless the ether is vibrating a certain way, then it can have resistance. But there's no resistance unless the ether has a wave in it. The whole ether doesn't move. The ether stays where it is. The matter moves through the ether, and it's only if there's a disturbance in the ether does the matter get disturbed. So again, I'm not arguing for the existence of ether, beyond the fact that I'm arguing for one that's active, not dead. And again, why call it ether then? Just call it ball bearings or baseballs or whatever.
And thus, the speed of light should be different in different directions.
So that's their straw man. An argument not made by anybody. Clearly an argument that if the speed of light is different in different directions because of momentum, that you could somehow add to the speed and you could subtract to the speed of light by moving. Okay, then obviously they would have to account for that and account for invariable speed all over the place, because all the light would be invariable all over the place then. So obviously that's not being the argument being made. So it just proves nothing to prove that light is a constant, because we already know that, right? That's sort of established by the fact that the forces all have the same speed. It seems quite obvious that that constant is a rock-solid constant, and you don't have anything called light except at that speed is what it leaves at. So no matter, I can only let light go. I can't push it into the world. I can only let it fly into the world on its own.
In 1881, Albert Michelson, the great American experimental physicist, does a remarkable experiment in Berlin.
Well, see, that's all this is. It's remarkable, and he was great, and one could argue that there's nothing blah blah blah. The only thing that came out of this, though, was the interferometer, which is the mirror thing, and that's not a bad little invention. But I'm saying it's a little dicey for some of the purposes they're using it for, because you are still putting light through a mirror or glass, both of which change its speed and not speed. It doesn't change the speed; it changes the distance traveled. So obviously, it changes how long it takes light to get from one place to another, because it's increasing the amount of distance it has to travel.
Michelson has developed an extremely sensitive optical device called an interferometer, and he uses this to compare the speed of light in different directions, and he finds no difference at all. So in 1887,
which, like I said, really shouldn't have been a huge surprise. Really shouldn't have been.
He repeats the experiment more carefully with Edward Morley in the United States. This new experiment would be able to detect...
Again, just recognize what the implications would be if they found a difference. If they found a difference, it would mean that matter was capable of this additive momentum thing, and that the ether was a resistance to momentum, and therefore, again, somebody would have to explain why there isn't any friction in the orbit of the Earth, why it doesn't quickly degrade.
Detect an ether wind of only 1 kilometer per second. That's just 3% of the Earth's orbital speed. But again, Michelson and Morley find no measurable effect.
Yeah, well, 3% of the Earth's speed is still only 0.0003% of the speed of light. So, this is all tricks they play here and there, where they're implying that they're measuring something very exactly. But no, you're measuring the speed of light. You're not measuring the speed of the Earth. And there is a difference.
The speed of light seems to be the same in all directions.
The real point is the speed of light you can't add momentum to it. The speed of light doesn't go where it's going. You can't push a photon. I guess that's the easiest way to say it, right? You can't push one. There's nothing you can move fast enough, get it, to hit the back end of a photon and make it go faster. You can sort of get that, can't you? There'd be no way to make something going fast enough to hit a photon in the ass. How do you hit a photon in the ass and make it go faster? Is that possible? Obviously not.
And that's a big puzzle.
No puzzle whatsoever.
Several of the greatest scientists of the late 19th century tried all kinds of ideas to explain the results. I'm thinking about the Irish physicist George Fitzgerald, and the Dutch physicist Hendrik Lorentz, and the great French mathematician Henri Poincaré. They said, well, maybe our laboratory instruments are also affected when they move through the ether.
Well, again, all you have to really do is understand that you can release energy. You can't push energy. Forces can't be moved. Forces go through things, they interact with matter, but you can't move a force. And light's a force. It can't be moved. You can only absorb it, reflect it, you can do something like that, but you can't push it.
Maybe they become distorted in space so they don't correctly measure distance, and so on. And maybe this happens in a way that just exactly hides these changes in the speed of light. This is close to the real answer, but it is not quite right.
Yeah, well, it's not even close, because your answer isn't the correct answer, so it's presumption that you've got it right is part of the problem with you fellas. So what else needs to be said? The very fact that that there was any physicist thinking that there was not anything but paradoxes in your way once you allowed light to change its speed, if you don't understand how that just opens paradox doors all over the place, obvious ones, I mean things that just can't fit with the observed reality, I don't even know why you would play with it, why it would ever be a question for anybody who thought about it.
Now, at about the same time this was going on, along comes Ernst Mach, an Austrian physicist and philosopher. This is the Mach in Mach number, by the way, which is the speed of an aircraft as a multiple of the speed of sound. And Mach made many discoveries in aerodynamics. But he also...
I wonder if he observed that sound is perpetrated, the wave is maintained. It can only exist in, okay, it can only be initiated through a medium, sound, by action that has to be faster than the speed of sound. Kind of important to this argument in the sense that if you really understood what it is, it's a wave, okay, a movement in the medium, and the movement has to be sufficient to break the barrier, the resistance between the atomic structure. So it has to be quick enough movement so there's no dampening. So it becomes, so it can't be spread out or moved or in some other way balanced against. It is enough movement where it actually pushes something beyond the speed, and then it has to do the dampening later. But I mean, it will perpetrate the vibration because it's excess energy. It's energy beyond the amount needed to get to the point it's rolling towards, and then it rolls past and then comes back, that kind of thing. It has to be more energy. Anything less gets dampened.
Wrote a sharp critique of the basic concepts of Newton's mechanics. So, Newton said that space has an absolute meaning, a meaning independent of the objects that are occupying space. Newton...
Yeah, well, there was nothing wrong with the way Newton is saying it. He's just clarifying that, look, let's understand there's a thing we call space, this nothing part, okay, the empty thing, the vacuum. And if you want to put something else in here, go ahead and do it. He's just saying for the sake of argument that there is a container, okay, and the container of non-events, and that events are happening in the container of non-events. The entire thing is not a solid thing. The entire thing is stuff in a container.
Also said that time has an absolute meaning. It's a meaning independent of processes that take place in time.
Right, and that was rather clever of him, just in the sense that clearly he had some indication that there's things that can't escape it. There's nothing escaping time. There's nothing instantaneous, truly, and that this clock is ticking in terms of it requires time for the apple to fall. And that fact that you can't do this distance thing, you can't make quanta go any faster. They're going as fast as they can, so to speak, based on what their dynamic is, what they're made of. Now, as you move the apple faster and faster, you will turn the apple into light, and then it goes the speed of light. But that's what light does. But apples have lots of other movement in them because it has energy from a lot of different directions inside of it. And it still possesses the mass of that energy.
And Newton said that the inertia of a body was an intrinsic property, independent of that body's relationship with the rest of the universe.
Right, so that means he believed that velocity was absolute, that it all added up. I mean, if you're in the solar system and it's going this way, and then the galaxy's going this way, and this is going that way, there's vectors that you can add up all these pieces, and you'll come up with a line that'll represent your absolute velocity. So I guess there's some way that I might be able to illustrate that, I don't know. So let's say around the Earth, around the Sun, you're going this way, and the Sun's going this way, so you add the Sun's movement this way, and then the galaxy's going that way, so you add that, and then you've got to do this by a time interval. But this is what you'll end up with, is some vector that'll be in the addition, well, it'll be more like this line, of those velocities, and this will be your true velocity on this vector at a certain total speed in one dimension.
Absolute space, absolute time, intrinsic inertia.
Right, intrinsic inertia, again, this is not quite exactly the way I would say it. It's absolute, it's absolute speed. That you are going some percentage of the speed of light. You have some percentage of imbalance. So you're either perfectly balanced, which means you're moving nowhere because everything inside of you have just as many fish going that way as 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 fish going that way. So in all three dimensions, you have balance, and the three dimensions are all balanced with each other, so there's absolutely nothing propelling you. You have again, I'll make the argument that the force around you is going to be vibrating you, so you do have a tremendous amount of acceleration, but you have no velocity. And then as soon as you start imbalancing, that is creating a circumstance where less fish are coming in one way, that means you're going to have more fish going the other way, and that circumstance, if taken to its extreme, will lead you to be a beam of light. So as you go faster, you become less material in the 3 dimensions and become more material in the 1 dimension you're traveling in.
None of these, Mach believed, were justifiable as basic assumptions.
Well, Mach was wrong, and you're wrong, and that's where you made a big mistake. Sorry, you just did.
So Mach said that physics needed to be rebuilt on a more reliable foundation.
Right, reliable meaning, let's find some unicorns. I mean, I don't know how that makes any sense at all. So you're going from something like, yes, there's absolute truths to the function here, to something that is mushy and breaks conservation. That is the separation of something like a time dimension. What sense does it make? To function, it clearly happens in the 3 dimensions. How the fuck could time be a 4th dimension, or a 5th dimension, or a dimension at all? To function in the 3 dimensions that exist.
So by the beginning of the 20th century, physics is in a state of confusion. And onto this stage comes Albert Einstein.
Yeah, it's not very good timing, I suppose. But yes, the confusion, I don't even, and Einstein, look, half of what he's saying is the exact opposite from what his legacy is. So that's the joke here, right? I mean, he's the one that starts talking about photon. He's the one that coins the term photon. And, yet it's now been turned into nothing tawny about it, into this stupid wavy mush.
Yeah, Einstein is something of a paradox. He's a shy, humble, good-natured introvert.
Sort of irrelevant. And what he is, well, I don't know about any of that shy or humble shit. And what he is, he's kind of abusive to his wife. And what do you call people who leave their kids? I ain't too good.
Yet, he's also the most celebrated scientist since Isaac Newton. Einstein is not a person of action. He's mostly lived in sleepy university towns and thought about the universe. Yet, he's a revolutionary figure with an influence far beyond science and academia.
Right, and most of that is based on a prediction that light is bent by gravity that was proven kind of fraudulently. I mean, with really poor, pitiful, weak evidence. And that has never been, in 100 years, confirmed with anything called hard evidence. And that's pretty spectacular.
Einstein was born in Germany, and as a young man he became a Swiss citizen, and then in his 60s a citizen of the United States. All 3 countries claimed him.
Who cares?
He was fascinated since childhood.
I mean, really, just don't do this personal crap, because it just looks like you're being, it just looks like you're just going to, well, we'll just talk about the parts that look good. And we won't talk about the parts that look bad.
By mathematics and physics. Einstein deeply appreciated the field theory of Faraday and Maxwell, and he also absorbed Mach's profound critique of Newton. And he set himself to the task of solving some of the most important problems in physics.
Yeah, okay, so he says this. I don't know if that was necessarily the inspiration for it. That's not exactly how they ever tell the story, but everybody has a different version of it, right? I mean, they tell the story, they saw the clock outside the patent window, and the clock got him thinking about time, and blah, 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 blah.
So our story opens in 1905. Einstein is finishing up his doctorate in physics at the University of Zurich.
Right, and he knocks up his wife, who was also a physicist. Her education is now suspended, And, and then he says, fuck you, bitch.
While working at the Swiss Patent Office to pay the rent. And in that year, he publishes half a dozen of the most consequential papers in the history of science. Now, 3 of the papers are on statistical physics, which is the subject of his PhD research. And these are very important papers. In fact, one of them includes a method by which the actual sizes of atoms can be determined. And that's how the sizes of atoms were determined a few years later.
Yes, averaging movements and all that kind of stuff. But I don't know what to say. I mean, obviously it's all stuff that there's nothing in this bent space thing that's anything new. It's just a way of drawing the inverse square rule, and there's not much else to it. So it's Newton's physics, and again, just with these little improvements that are almost microscopically small improvements. I mean, important, but microscopic.
One of the papers is a revolutionary advance in quantum theory, for which Einstein would eventually receive the Nobel Prize in Physics. But the 2 remaining papers are his most famous work, the work that concerns us now. First one.
Yeah, well, the other paper was kind of important just because that's the one where you find out that there's a quantity to this photon thing, that when it hits metal it actually is conservational, and that what goes in is coming out in the form of another form of force and energy.
In June, lays out Einstein's special theory of relativity. And the second one, in September, is a second short paper on relativity, which includes the most famous equation in the world, E equals mc squared.
Which, like I said, I wish Einstein took more seriously, in the sense of understanding that matter is energy. It's not just that there's a proportional relationship. The relationship is complete, in the sense that energy still exists, and the energy will not in any way be remanufactured. It's just going to be released.
So, what is it all about?
Matter is essentially a battery. That's what E equals mc squared is basically saying, is energy goes in, energy stays, energy can leave. Matter's a battery.
Well, in 1905, Einstein is thinking about Galileo's ship. Recall that Galileo imagines doing various experiments in a smoothly moving ship. And he finds that no mechanics experiment, that is to say, no experiment about force and motion, can detect that the ship is moving. And this...
Right, and that's because we can't do any force and motion experiments anywhere near the velocity of force. So force has a velocity of 168,000 miles per second. 160,000 miles a second. And we're going to talk about the differences that will be created in the experiment when we're going 8 miles an hour. 8 miles an hour. So like a million plus times slower. I mean, obviously, you know what I'm saying. I'm just saying that quite obviously, if you could do these experiments at these actual speeds of the force, you'd be able to tell the difference, because you would recognize that your matter can't even produce light anymore when you're going very, very fast. There's no flashlight anymore. The flashlight is 16 miles long, and its material structure is so degraded that it cannot produce light. And if it produces light, the light can't possibly outcompete the thing that we are now, because we're moving, say, 3/4 the speed of light. Well, then the light that leaves will only be leaving at 1/4 the speed of light, in the sense that it will only beat us to a target by that 1/4 speed.
is why we cannot feel the motion of the Earth through space as it orbits the Sun.
So another one, we can't feel the orbit, and to feel it would mean that we would have to feel the force, and again the force is moving 1,000,000 times faster. It's at a frequency, so to speak, or something. So why would there be any expectation that we could sense things on that scale? Vibrations, we can't hear certain sounds. These sounds are 1,000,000 times faster than the sounds we can't hear. It's like we can't. You could sort of understand that maybe if I touch something really, really fast, so fast, very, very high frequency, it won't feel like a touch anymore.
This is Galileo's principle of relativity.
Right, and it's just wrong. Okay, it's a principle based on a world, a presumption that's just kind of silly in a way. All the forces, the real forces, magnetism, electricity, light, gravity, they're all moving the speed of light. They're just not something you can use our common material motion and say, I'm going to use our slow material motion and make an experiment applicable to force law. It's silly. We can't go as fast as force, and you can't slow force down to our speed. So you can't possibly know the truth beyond the fact that you can do some logical intuitions and understand that if light has a constant speed, no matter what source produces it, you can just do the logic, okay, that if I'm moving the speed of light, there's going to be a problem in me producing light that gets somewhere faster than I do, because it can't.
But if the ether idea is right, you could detect the ship's movement through the ether. How?
Well, again, see, this is another, if the ether argument is right. You mean the straw man ether argument. Because again, nobody rational would make an ether argument talking about ether wind. Because if they did, they'd have to explain why the Earth hasn't crashed into the sun already. So I don't think Maxwell was doing that. I don't think Maxwell was suggesting that there was ether wind.
By doing an electromagnetic experiment, like measuring the speed of electromagnetic waves, the speed of light, in different directions.
Again, electromagnetic waves. Again, they always have to say this wave thing, even though there's no evidence of a wave. No evidence.
And so Einstein asks, all right.
So I guess that's the setup. They're saying it's a wave because they want to disprove the medium that the wave is moving through. So then they can make a wave that doesn't have to move in a medium. That doesn't make any sense. What if ship is moving at the speed of light? Light could not move forward in the lab at all. There we go. Let's see what he does with that.
What if the ship is moving at the speed of light? Then light could not move forward in the lab at all. That would be very different from being at rest. So the principle of relativity would just be wrong.
There you go. Right. Yeah, you got it. How do you fuck this up? I mean, you got the right answer. Now show me. Now you're going to really try to tell me that's not correct. You're really going to do that. Okay, let's listen to it. So your lab's moving the speed of light. You realize, hey, we're already moving the speed of light, and if I shoot the light that way, I can't do it because we're going to get there just as fast as the light. So obviously, that ain't going to work. And if I shoot it the opposite way, let's see, I have to think what the implications of that are. Then we look like we're moving twice the speed of light. You can't do that.
But to Einstein, this seems too high a price to pay. So Einstein proposes a bold idea. He says, maybe we cannot detect the motion of the ship, even by speed of light measurements.
Well, there you go. So that's where they just break it, right? Somehow we can't do it, even though we know for a certainty, I guess I'm just saying logically, that the experiment's already, you can do it in your head. You can do it in your head. You say, I'm moving a flashlight the speed of light. even if it were possible for a flashlight to go the speed of light and the matter didn't turn into light, even if it stayed a flashlight and it stayed a light bulb and it stayed batteries and it could produce electricity and it could produce light, it's just a known that there's no way, if you're going the speed of light and you're pointing the flashlight in front of you, there's no way the light coming from the flashlight can get to the target faster than you, because you're both going the same speed. Duh!
After all, Michelson and Morley couldn't. Einstein says we should elevate the principle of relativity to a fundamental law governing all of physics.
Right, so just pretend that what I just stated isn't true, and that somehow we're just going to pretend that isn't true. We're going to pretend a paradox is possible, that the flashlight somehow is going to stop moving, even though we know it's moving the speed of light. We're going to pretend it's not moving and that it's shooting light. So that's more logical to you people. Let's pretend it doesn't move, even though you know it's moving. So it cryogenically gets frozen by moving the speed of light. And now it can produce light. That's essentially what they're doing, which is just nonsense.
Mechanics, electromagnetism, and beyond. And if some of those branches of physics need to be modified to make this work, so be it.
Right, so be it. We'll just break logic. We'll ignore that paradoxes are evidence of a problem in your theory. So if your theory creates a paradox, you need to resolve the paradox, not sit there and pretend. You can just say, I'm going to fix the paradox by breaking the fundamental rules. We're no longer going to be logical. Okay, we're going to allow things to do things that are magical. And that's all this comes down to, is you're now giving something a magical property. The ability to break time.
Here are Einstein's basic postulates. The first postulate is that every observer, whether at rest or in uniform motion, sees the same general laws of physics.
Well, again, that's not even true, because you're saying that if I move him at uniform motion at the speed of light, that he's going to see light leave a flashlight, and he's not.
And the second postulate is the speed of light, c, is the same, independent of the motion of the source.
Right. Now, that part is correct if you went just that far. You can't make light go faster. Light will always leave the flashlight at the same speed, no matter what speed the flashlight is moving. But your speed is still speed, and if you're moving half the speed of light, you turn the flashlight on, the truth is the light will only get ahead of you at half the speed of light, because you're moving half the speed of light. So it's still moving the speed of light. It's just that you're moving half the speed of light, so you're going to maintain a closer connection to that light, and you're therefore going to change the amount of time it takes to get to the target, in the sense that you will arrive at the target much obviously sooner than if you weren't moving, obviously.
Therefore, it follows that every observer, at rest or in uniform motion, must measure the same speed of light in every direction.
Right. Now that would be true for light coming at it. Light produced by some other source. But again, light you're producing while you're moving, the matter is moving and producing light. This doesn't apply. So this is where this is a deception. Because if you're producing light and you're at uniform motion, your motion will change the light substantially. It will make it even impossible for you to transmit light. If, say, I try to shine light perpendicular to my movement and I'm going half the speed of light, the light will not create a ray of light. It will not. The photons will not be perceivable. They won't have any connection to each other. their frequency will be broken in the sense that their vectors will not line up, and they can't possibly be absorbed by any electron in the universe. So if I shoot light perpendicular to my speed, that light will be substantially degraded.
Now, this is impossible to reconcile with the ether theory. So, we get rid of ether theory.
Right. Well, it's impossible to reconcile it with your straw man version of the ether theory. Again, I'm not defending ether theory. I'm just saying that these people cheated to pretend that they gave a salient argument against an ether by creating a fake proposed ether and tore that down. This is a straw man argument, and bogus is bogus. Ether is bullshit, but this argument is bullshit.
But we keep Maxwell's beautiful equations about electric and magnetic field.
Yeah, well, obviously the equations are just an acknowledgement that essentially basically points out how, well, magnetism and electricity are a lot like gravity. Okay? It's the perpendicular thing is the nice thing too. I mean, establishing the idea of the force being expelled in the perpendicular dimensions. The dimensions, when you gain acceleration, the acceleration's going somewhere. You get it? I mean, you can't get it from nowhere. So if you're gaining mass in one direction, you have to lose it in the other directions. I mean, that logic is just so, oh yeah, that makes sense. If you're trying to move in one dimension, the speed of light going in one direction, that means you have to go in one dimension. And what is slowing you down? Oh, that's right, the stuff moving in the other dimensions. You have to get rid of that. It's the baggage slowing you down.
This idea is also a bit counterintuitive. Suppose I stand at rest and I shoot.
Ah, good. They're actually going to use the flashlight example, and I don't know how did they. How are they going to make this make sense? To pretend the flashlight isn't problematic.
A beam of light at speed c. You pass by me at speed 1/2 times c in the same direction. So how fast do you observe the light beam going? Well, common sense says that you observe the light beam traveling ahead of you at 1/2 times c.
Let's understand, we can't see a light beam do that. We can only know where light is based on where it hits something. So let's understand, we can't see the light progressing through space unless we put something up there to mark where it is at any place in space. So, this is a little bit silly talking about seeing the light. You're not going to see it that way. I mean, you should have just talked about something moving the speed of light.
And Einstein says, no. You would observe the same speed, c, for the light beam.
Well, see again, now does that make any sense to you, right? Okay, I shoot a flashlight. You're moving half the speed of light in exactly the same direction. And somehow it makes sense that you're going to see the light that I'm shining hit something when it's like in the far distance at the appropriate time. Even though you're moving, you're closing that distance. So you keep making the distance shorter and shorter because you're moving half the speed of light. So you're going to see it at a different time than I'm going to see it because I'm not moving half the speed of light. Obviously, it's going to take twice as long for me to see it hit the target as it'll take for you to see it hit the target because you're moving in the same direction as the light, for fuck's sake. You're shortening the distance, which is the same as shortening the time. I mean, distance is time, time is distance. You can't separate them.
So how can this be true?
It's not. You have no evidence it's true.
Einstein's answer is profound.
No, it isn't. It's just kind of silly.
The world consists of space and time. Different observers measure space and time in different ways.
No. Matter is changed by velocity. Yes, you make matter go faster, it loses its dimensionality, which means it loses its function as matter, as a metabolism. So if the wheel is spinning, rotating, and then I like the dancer example better, but yes, you're dancing as fast as you can. And then I say, move to the right. You're not going to be able to dance as fast because certain footsteps now have to be to the right. Those will occupy distance, which means they'll consume time. So you won't be able to dance as fast. The same thing happens to your material matter when you're in motion. Velocity degrades material function in the sense it takes longer for one orbit of an atom, so to speak, a rotation to take place. All rotations are now slowed down because you're basically expelling with velocity the tangential elements of that rotation, and you're lengthening the wheel. So the wheel's getting longer and slower.
These differences are exactly what make everything consistent.
Right, so that's just, again, there's nothing rational in that argument. We're just going to break time, is all they just said. We're going to pretend time changed, not the thing measuring the time. And some of these people will actually concede that the clocks break, that you're measuring it wrong. And that if you really thought about it, it's your broken ruler, not that you have really negated the fact that if you're running half the speed of light in the direction of a beam of light, that the beam of light will appear to arrive at its destination faster because you're shortening the distance it's traveling, essentially. From your perspective.
The different observers will actually agree about quite a lot. They'll agree about the general laws of physics.
So again, we're back to this again. All observers will agree. No, if you're moving the speed of light, you're not going to agree. Because everything coming at you, let's say you're moving half the speed of light. All the light coming at you is now not visible light. It's X-rays, gamma rays, it's gained in frequency. If you turn around, okay, anything coming from behind you is doing exactly the opposite, which is just turned into radio waves or something, stretched out and invisible. So everything in front of you has become more massive. Everything behind you is becoming less massive. There'll be nothing similar about the world you'll see. So if I moved you half the speed of light, and right here, we're sitting here side by side, and you go half the speed of light, you're not going to see the same thing I'm going to see. If I move you half the speed of light and you're going around in a circle, so you can keep coming back to this one point, okay, you just keep going half the speed of light. The point is, when you wish through this moment, this space,